Good day, viewers. Welcome to Simplified Chemistry channel. I want to say thank you once again for subscribing and liking our videos. Please go to the comment section now. Tell us the topic you want us to discuss. Go to chemistry channel, our chemistry channel, the comment section. Go there. Tell us the topic you want to teach. Uncle, teach me this topic. Put it on the comment section. At the end of today, we are going to be doing a survey, and the topics that has the highest number will be discussed in next video. Welcome once again. Today we are going to be talking about formula. And we are going to be seeing two formulas are going to be discussed today. After discussing about the representation of chemical equations, we need to talk about the formula in calculating some chemical equation. We are going to be talking about empirical formula. We are going to be talking about molecular formula. What are the things that we expected to learn today? At the end of the class today, we shall be knowing how to calculate empirical formula and the definition of empirical formula, molecular formula, and the definition of molecular formula. What are the things they do ask in exams? Number one, they can ask us the definition of any of these 10. Number two, they can ask you to differentiate between empirical formula and molecular formula. Stay tuned. Please don't forget, go down to the comment section. Tell me, Uncle, I want you to teach us this topic. Then fix the topic you want us to discuss. Now, empirical formula, as it's been written on the board, is the simplest formula which expresses the ratio of the components. Please take note the word of the ratio. The ratio of the components, elements in a compound. The ratio of the component of elements in a compound. While molecular formula of a compound represents the actual numbers of atoms in a molecule of that element. I repeat, it represents the actual numbers of atoms in that element, in that compound. Take note, the difference between them. This one will express the ratio of the element, but the molecular formula will tell us the actual numbers of atoms present in this element. Actual number of atoms present in this element. Let's quickly discuss about one or two examples and see how it is being calculated. Example one on empirical formula. Let's see how to calculate empirical formula. Example one. Let's write. A compound contains 28.6% of magnesium, 14.3% of carbon, and 57.1% of oxygen. Calculates its empirical formula. Now, we have three steps that we should know when we are calculating empirical formula. Number one thing you should not mix is that when you are answering question on empirical formula, as it is given to you by the examiner, that's how you are going to arrange your elements. Don't interchange the elements involved. You can see 28.6% of magnesium, 14.3 of carbon, 57.1 of oxygen. Please don't rearrange. That's number one thing. You should know the solution. So let's represent them. Number one, we have magnesium, we have element carbon, and we have element oxygen. Number two, you have to get the percentage composition of each element represented. Percentage composition of each element represented. Percentage composition. At times they might give you percentage composition. At times you have to look for the percentage composition by multiplying the mass of the element by 100 divided by its total mass in the compound. Percentage composition. What are the percentage composition given to us? We have magnesium 14.3. We have magnesium to the what? 28.6. Then carbon 14.3. Oxygen 57.1. Step 1 completed. Step 2, we are going to divide them by the relative atomic mass of each. Divide by relative atomic mass. Relative atomic mass of each element. Relative atomic mass of each element. Magnesium 28.6 divided by 24. Carbon 14.3 divided by 12. Oxygen 57.1 divided by 16. Notes: in some examination, the relative atomic mass of each element will be given. And in some, they believe that you should be able to know the relative atomic mass. How do we get the relative atomic mass? By adding the what? The atomic number plus the proton number, the neutron number, you get your atomic mass. So what do we do now? Divide across. Divide across. I believe you are also pressing your calculator as I'm doing mine. Yes, 28.6 divided by 24 is going to give us 1.19. 14.3 divided by 12 is going to give us 1.19. And 57.1 divided by 16 is going to give us 3.57. 3.57. Are we together? 3.57. Let's do our confirmation again. 57.1 divided by 16. It's giving us what? 3.57. After getting this, we divide by the smallest. Divide by the smallest value. Divide by the smallest value. Let's divide by the smallest value. Divide by the smallest value. Divide by the so 1.19, 3.57. You all agree with me that 1.19 is the smallest value. So let's divide. Divided by 1.19. So 1:1:3. 1:1. You round off in case you're having fraction to the nearest whole number. Round up to nearest whole number. So we have 1:1:3. So therefore, our empirical formula becomes Mg, which is 1, and in chemistry we don't write 1. Some students will write it this way: carbon 1, oxygen 3. Wrong. Your empirical formula is MgCO3. 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 That is our empirical formula. That is our empirical formula. So how do we do it? Number one, get the percentage composition of each element. Number 2, divide by its relative atomic mass. After getting your value, you divide by the smallest figure. Divide by the smallest figure, then you get your answer. This is simple way to calculate your empirical formula. This is the simplest way to calculate your empirical formula. Don't forget, go to the comment section. Go and tell me, Uncle, I want you to teach me this topic. Uncle, I want you to teach me this topic. And we will get across to you. In case you have any doubt on what we've taught, please don't fail to express yourself also in the comment section. Thank you. See you some other time.